So we're continuing on question 3. We are at part D. So part D, the second part of D, it's the development from the first part. All right. So we, in the previous video, we have proving that cos 2 theta is equal to 2 cos square theta minus 1. So we have proven that in the previous video, and now we're asked to solve the equation cos 2 theta plus cos plus 1 is equal to 0, where theta is less than 2 pi and it's greater than 0. All right, so what we're going to do here though is just to employ some substitution quickly. So let's write the question. So the cos 2 theta plus cos theta plus 1, and this is equal to 0, and we're dealing with where theta is less than 2 pi and it's greater than 0. So it is our intention to solve this. Note that the question says hence, right? Which means that our response to this will be coming from the response we had earlier. All right. So we're gonna substitute 2 cos square theta minus 1 for cos 2 theta here. So we're gonna substitute there. So having gotten the fact that cos 2 theta is equal to 2 cos square theta minus 1, we're going to substitute this right here. So let's do that. So we're going to be writing 2 cos square theta minus 1 plus cos theta plus 1 equals 0. From this, we could simplify, like we could put the like terms together. For example, cos square theta can go with plus cos theta, the negative 1 with the positive 1 equals 0. This becomes 0. So in the final response, we have 2 cos square theta plus cos square theta is equal to 0. We're going to factorize out cos theta. So we'll have 2 cos theta plus 1, which is equal to 0. Remember, two things multiply to give us a 0. We could say either cos theta is equal to a 0 or 2 cos theta plus 1 is equal to a 0. Hold on, let me put my 0. Is equal to a 0. So we have two situations that we want to look at. Now, let's view situation 1. Cos, if we have a case that says cos theta equal 0, to find this angle, we're going to have cos, we're going to do the inverse or the arc cosine. So we're going to be looking at cos inverse 0, and it's going to give us the angle. If you're working in degrees, that would have been 90 degrees or pi over 2. But if we're working in, say, radians, then inverse cos of 0, we're going to get that the value is 1.57. This is equivalent to 90 degrees. All right. So what we want to look at, this is neither positive nor negative, but this is when the value of the angle gives a 0. All right. So this is neither positive nor negative. So if we view the quadrants, and we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. we do have 0 here. We have pi over 2 here. We have pi there. We have 3 pi over 2, and then our 1.5 pi. And by the time we reach here, we go back to 2 pi. We're suggesting that cos is 0 here, and it's going to be 0 here. Right? So it's not in the quadrant. It is actually at these places. So this value here, the second value for this is still going to be where, so this is 1. The second value, as we move from 0 all the way around to 2 pi, we're going to capture another angle there. So we're going to be adding pi to this. So our second response, solution 2, is going to equal to pi plus 1.57. So if we are adding that to pi, so we are adding pi plus 1.57. The second response is 4.71. So these answers are radians. We're working in radians, and that's radians. So these are 2 of the solutions where theta is equal to 1.5 radians, and the next one is where theta is equal to 4.71 radians. And as I suggested, that's like a 90 degrees and a 270 degrees. But so it's pi over 2 and 3 pi over 2. Now, let's go further. So we work out the first response. The second response here, as you could see, 2 cos theta is equal to -1, subtracting 1 from both sides here. We're going to divide by 2, divide by 2. So cos theta is equal to -0.5, which means if we want to find this first value, we're going to have to say cos inverse of -0.5. That's going to tell us theta. I could tell you that the negative values for cosine will be in the second quadrant as well as the third quadrant. So we're talking about in these quadrants here, second and third quadrant. All right. Now, let's go. Let us see what's going on. So we're looking at putting this together. If we go inverse sine, inverse cos of -0.5, we're going to get that theta is equal to 2.094 radians. So this is one of the solutions, which is somewhere here in that quadrant. All right, so from here to there, we're dealing with this, which is about 2.094 radians. This acute angle here is very necessary because we need to add it to pi to find the related angle in the third quadrant, because cosine is negative in the second and in the third quadrant. So then let's find that acute angle that we would need. So the acute angle is just to say, guess what? You could see here, if I just take this 2.094 from pi, I'll get the angle here. So if I take the 2.094 from pi, I'll get that angle that I need. So pi minus that is going to give me my acute angle. I need to find my acute angle right there. So I'm going to minus 2.094. And I'm going to get that the acute angle that I need to use is 1.047. So I need that acute angle. to find this down here. So now, the last angle that we need is to add that acute angle to pi. So we're adding it to pi so that we could find the angle in the other section. So we're talking about pi plus 1.047. And this will give us 4.19 radians. So there it is, that we would have come up with those solutions. So finally, here are the last two. One of them is where theta is that, and the other one is where theta is 4.9. All right. So thank you for watching Daily Maths Concepts. If you have not yet subscribed, please do so. Like and share the video. See you next time for question 4.